So here we have some land, and we're going to have some water, okay, forming a beach in a second here. You should know this, though. You should know this. Wind causes waves. Wind causes waves, okay? Energy is going to be transferred from the wind to the water, causing waves to occur. The bigger the wind, the bigger the wave. Now, here's something that's going to occur. As the water, let's say we've got a nice light breeze here. As the water starts to approach land, something starts to happen to the waves. The waves start to get bigger. See if you can pause the video and just take a guess. Why do you think that this is happening? Okay, as the waves continue to get closer and closer to the shore, their height is going to increase. So as the depth of the water decreases, wave height will increase. And the reason that this happens is that the actual water is going to be displaced up. It's going to be displaced higher and higher because there is less room for it to actually travel. The volume is going to be displaced up until it eventually crashes on the beach. And when it crashes, it's going to cause erosion and take some sand with it. And that's what we're going to look at right now. Okay, so you should know that wind causes waves, wind transfers energy to the water, and as depth decreases, the wave height is going to increase. Okay, let's go ahead then and take a look at our presentation here. Okay. Okay, so as I just showed you guys, as energy blows across the ocean, waves are made, and energy in the form of wind. As the wave approaches land, friction between the wave and the bottom of the ocean slow down the wave, causing it to become bigger until it breaks. So there's going to be an increased amount of friction that occurs because there's more and more water piling up on top of itself. If you guys watch this GIF, it explains what happens. Wind blows across the surface, makes tiny ripples. The bigger the wind, the bigger the wave will be. Waves erode the shoreline and deposit the sediment as sand on the beach. And then the definition of a beach is pretty simple. It's just an area of wave-washed sediment along a coast. Now, you'll notice that the definition of beach does not include sand. Does not include sand. Go ahead and pause the video and see if you can tell yourself, why wouldn't it include the word sand when talking about the beach? You should have said something to the effect of that not all beaches have sand on them, right? Some beaches have rocks on them. Some beaches are filled with shells. Some beaches are filled with volcanic ash. It just depends on what's being eroded. Now, in this GIF over here, we see a cliff being eroded. There's a pretty good chance that that soil and dirt and sediment that makes up that cliff will become part of a beach. So we have another process here called longshore drift, and I'm going to go ahead and show you an illustration of what's occurring in a second. But longshore drift, you should know that as waves hit the shore, they come at an angle. This angle causes a current that will run parallel to the coastline. This causes sediment to be deposited down the beach. If you guys watch this GIF over here on the right, it's explaining and illustrating what exactly will happen. It happens really, really slowly, and eventually all of that sand, all of that sediment will get stuck somewhere. Typically, that's what occurs. So watch it one more time here. You see the wave coming in at an angle. And that sand particle is going to get drawn back out. This is the process of longshore drift and is a way that sediment can be moved across an actual beach. So this information can be found on pages 252 through 255 of your textbook. Now let's go ahead and switch over here. Let me show you one more thing here. Okay, so you'll see here that I've drawn a beach and we have a jetty over here. And then we're just going to illustrate the process of longshore drift. So we know the wave is going to come in at an angle and then it's going to backwash out. And as it comes in and backwashes out, it's going to take a little bit of sediment with it. It's going to take that sediment with it, and it's going to come in at an angle. It's going to backwash out. It's going to come in at an angle and backwash out. Now, go ahead and pause the video and see if you can take a guess. What is going to occur along the jetty here? What do you think will occur along the jetty? Okay, eventually a bunch of sediment is going to get built up along the jetty and going to start settling around the jetty. This is where then longshore drift is going to cause different amounts of sediment to actually settle. This right here is the process of longshore drift. And as a way that sediment is eroded and deposited, eroded and deposited, eroded and deposited.